Yes, different RAID levels now we are going to see. RAID levels we have a different combinations of activities. It starts from 0 to 6. RAID 1 it is a striping, then RAID 1 it is mirroring, and RAID 2 it is a bit level striping with a dedicated party, and RAID 3 it is a byte level striping with a dedicated party, and RAID 4 it is a block level striping with a dedicated party. Then RAID 5 it is a block level striping with the distributed party, and RAID 6 is a block level striping with the two parties. RAID 0 striping it improves the system performance by splitting data into smaller blocks and spreading them across multiple disks. This process is called striping. It enhances data access speed by enabling parallel and read-write operation, but provides no redundancy or fault tolerance. But it provides no redundancy. Repeated data it is not possible to store in that particular things of activities. Only the new things it is possible to store in the RAID 0. Then RAID 0 concept, disk 0, disk 1 and disk 2 and disk 3, it comes under 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. A set of blocks distributed across the disk forms stripe. For instance, 0 to 1, 2, 3 is one stripe. For example, this is the one stripe, this is the second stripe, this is third stripe and fourth stripe. Instead of placing just one block into disk at a time, we can work with two or more blocks placed into a disk before moving on to the next one. Benefit, it is easy to implement, it utilizes the storage capacity in a better way. Limitation, a single drive loss can result in the complete failure of the system. It is a major drawbacks in the RAID 1 0. It's not a good choice for critical systems. When you are going to store a very important document means, so RAID 0 it is not advisable one, only we have to follow some other approach concept. Go for the RAID 1. It enhances reliability by creating an identical copy of each data block on a separate disk. This ensures that even if one disk fails, what will happen? The data remains accessible from its duplicate. While this configuration is highly reliable, it requires a significant storage overhead. Only the thing we have to follow the significant storage overhead. We need a very good storage media. Then we will take it to consider our database as a mirroring concept, because each and everything it's having one duplicate copy of activities. For example, here disk 1 0 is there, disk 0 in 0 is also there, disk 1 also 0 is also there, disk 2 1 is there, then disk 3 that mirroring approach is there. Then each and everything it's having some mirroring approach, so it is very reliable and highly secure also. Mirroring, each block of data is written of two or more disks. For example, block 0 is stored on disk 0 and its duplicate on disk 1, and block 1 is stored on disk 2 and it is duplicate on disk 3. Mirroring level 2, in the figure, mirroring level 2 indicates that there are two copies of each block. Yes, we have two copies of each block distributed across different disks. RAID 0 was unable to tolerate any disk failure. Yes, it is possible to tolerate any disk failure, but RAID 1 is capable of reliability. Benefit, it covers complete redundancy. It is possible to complete redundancy, it is possible. It can increase the data security and speed. Most of the companies, they are started using this mirroring concept. Automatic mirroring concept is also there. It is highly expensive, storage capacity is less. Yes, it is highly expensive because we are copying each and every process of activities one more time, so it's highly expensive. Then RAID 2, bit level striping with a dedicated party. RAID 2 is a specialized RAID level that uses bit level striping combined with error corrections using Hamming code. It is a very famous one. In this configuration, data is distributed at bit level. one by bit level, it will transferring to the storage media. Across multiple drives, we have a different type of drives. In that each drive, it is possible to store bit level. And a dedicated party drive is used for error detection and correction. Suppose we are facing some errors in our storage media, or we have to correct that one, means it is possible in this approach. While it offers strong fault tolerance, it is possible to avoid the strong fault tolerance. Its complexity and cost make it rarely used in practice. Because it's having that memory style and error correcting code, it is totally different. So it is very difficult to understand by the common user. Benefit: in case of error correction, it uses scamming code. It uses one designated drive to store party. Then limitation: it has a complex structure and a high cost due to extra drive. Then it requires an extra drive for error detection also. Correction, we have some drive, and detection also we have some drive, so it is highly costly. It is possible to manageable things also, it is very difficult. But the concept, what is the concept they are implemented here is scamming code concept. Write 3, it is byte level. Previous one, it is bit level. It is a byte level striping with a dedicated party. Now we will see one by one. Write 3 concept, how we are implementing here. Wait.